Hello everyone, we're continuing with day 19. I spent a few hours trying to do day 18. I uploaded one very long video that concatenated a few videos, and I simply try after that once more and wasn't able to do any progress despite the fact how many types of strategy I tried, and I simply decided to move on and to try day 19 and probably in the future to go back to day 18. I actually kept my previous attempt, my prompts and so on of the things that I tried. As you can see, it's a lot of attempts. I try with different services, with not only with GPT-4 but also with Saga. I tried with Code, and all of them, none of them solved the problem. And I tried multiple times with all of them with different programming language and so on. But back to day 19. Let's try to read and see if we'll have more success, or simply we'll have mark this task like a task that cannot be solved with, at least with the techniques that I'm using with ChatGPT. As your prop drifts down through this area, it realizes an assortment of bacon and scanner into the water. It is difficult to navigate in the pitch black open water of the ocean trench, but if you can build a map of a trench using data from the scanners, you should be able to safely reach the bottom. Okay, we'll need to navigate. The beacon and scanner float motionless in the water. They're designed to maintain the same position for a long period of time. Each scanner is capable of detecting all beacons in a large cup centered on the scanner. Beacons that are at most 1000 units away from the scanner in each of the three axes X, Y and Z. Okay, it's three-dimensional. Have their precise position determined relative to the scanner. However, scanners cannot detect other scanners. Okay, the submarine has automatically summarized the relative position of beacons detected by each scanner. Your puzzle input. Okay, however, the submarine has automatically summarized the relative position of beacons detected by each scanner. That's like a summary. Let me see how the input looks. Oh, scanner 1, 8 have everything concatenated. Okay, in one list. Let me go back, and then we have all of the scanners. That's our input. For example, if a scanner is at XYZ coordinate 500 0 and minus 500, there are beacons at the scanner could report that the first beacon is at relative to the scanner. Okay, in this case what I'm doing is I'm moving my coordinate system, this X, Y, and Z, simply to be where is my scanner, and from this point I'm calculating, okay, now I have minus 1,000, and actually it's only minus 500 according to this absolute the Cardian coordinate system, which is in the center. Okay, and I need to adjust my coordinate based on that, but would not detect the second beacon at all because it's one more. Okay, it's detecting simply up to 1,000, and this one is 1,001. Okay, unfortunately, while each scanner can report the position of all detected beacons relative to itself, the scanner do not know their own positions. Okay, I'm getting, so to say, these coordinates, but I don't know this X, Y, Z0. I'm getting this one, and they're adjusted to this one. You need to determine the position of the beacons and scanners yourself. Okay, I have only the positions of the beacons, but it's so to say without knowing the origin from which each of these positions are made. The scanner and the beacon map are a single continuous 3D region. This region can be reconstructed by finding pairs of scanners that have overlapping detection regions such that there are at least 12 beacons that both scanners detect within the overlap. By establishing 12 common beacons, you can precisely determine where the scanners are relative to each other, allowing you to reconstruct the beacon map one scan at a time. For a moment, consider only two dimensions. Suppose you have the following scanner reports: 024133. Okay. In this other scanner, drawing X increasing rightward and Y increasing upwards. Rightward and Y it's increasing upwards. Okay. It's like that and that. It's not like that and that the typical use in graphics. Scanner S as beacon as B, scanner 0 detect these beans, scanner detect these beans. Okay. For this example, assume scanner needs 3 overlapping beacons, then the beacon visible to both scanners overlap to produce the following complete map. Unfortunately, there is a second problem. The scanner also don't know their rotation or facing direction. Okay, due to magnetic alignment, each scanner is rotated some integer number of 90-degree turns around all of the X, Y, and Z axis. That is, one scanner might call a direction position X, while another scanner might call that direction negative Y. Oh no, they're also with not aligned coordinate system. They're or two scanners might agree on which direction is positive x, but one scanner might be upside down from the perspective of the other scanner. In total, each scanner could be in any 24 different orientation facing position, negative x, y, or z, and consider any of the four directions from that facing. Okay, and here it's example. By finding pairs of scanners that both see at least 12 of the same beacons, you can assemble the entire map. For example, consider the following report. Okay. Because all coordinates are relative, in this example, all absolute will be expressed relative to scanner 0, using the orientation of scanner 0 as if scanner 0 is at coordinate 0, 0, 0. Okay. Overlapping detection cubes. The 12 beams they both detect relative to the scanner are at the following coordinates. The same beacons, following this process, scanner 2 must be at relative scans and scanner must be relative to scanner 0. The full list of beacon relative to scanner 0 is okay. Then what's my task? How many beacons are there? Okay, that seems quite hard task, but more understandable than the previous one. Let's see. I would imagine that most of this stuff I will need to delete it because it's simply the token size of the let me go here and you can see it's already the token size is too big. Okay, let's delete this sentence, doesn't tell us anything, and graphs tokens. Probably before to finish that, let me simply close that, copy day 17 and paste it here because unfortunately day 19 thought to be more successful than day 18 that simply failed. Let me delete the program here, the inputs. Let me grab the actual input from here. Let me go and grab some test input. I think this example make perfect sense with these 4 scanners. And here what we want from our algorithm is the same thing. We ask for You're a prominent competitive programmer, you've been invited to participate in programming competition, and you need to write a Go program that solves the task and read the input from a given file. Okay, now we have this setup. Let's complete the message. For a moment, I think shouldn't consider that, because our language model for a moment consider that, and the language model would think all the time that it's two-dimensional. We don't want to confuse our language model. Bye and simply to waste our tokens for absolutely anything. Bye. Unfortunately, there is a second problem, blah blah blah. What about this? For example, here is his regimen. Okay, we don't need all of them. Let's keep 3 of them. Yeah, exactly. We have 3 that are the same position, but by filtering parts of scan, in here it's one example with probably we don't need this relative position and so on. It's a bit our position blah blah blah. We don't care for this one because we want to keep the our again it's simply too much of a token size. Let's try with this one, but I think it's unfortunately too big. Let me give a try. I think we'll need to delete most of this because this is the visual stuff that it's showing. Yeah, I think will in general wouldn't work. The idea. Okay, it's interesting. We have absolute position, the bacons, and we have this kind of IDs, 0 number and so on. Actually makes sense. What is this copy function? Very interesting thing is that yeah, the most challenging problems, they were so to say, very challenging, at least in advent of code, because of their way of how they've been formulated. It's not, so to say, something that it's simply formulated like Fermat's last theorem, but simply to be challenging to prove it, because it's required, it's simply too complicated, or you need to come up with something very clever. Here, the difficulty of most of the problems seems to be related to how bloated their formulation is. If they're really bloated, they're like simply hard for a person to understand them and to simply solve them because of this bloatiness. Here, okay, I think that soon we'll run out of tokens for and so on. Let's see how much of this parsing would be really working. Okay, that seems about right. So far the solution looks pretty decent. It's using this coordinated map, so on. Yeah, let me go program and simply cut the program up to here. And my second prompt is prompt 2. Let me mention that we're dealing with GPT-4. Could you complete the main function? Please skip all the other functions. Implementation. I have. And one interesting thing is here, when I'm saying to complete the function, I want to compare how much from the original one stays in the final main function. You can see it's actually quite I think might have enough space to continue it and complete it, but let's see. Very frequently OpenAI have some network errors and some many technical problems. Not sure even with enough tokens that we'll be able to have it completed. Although here you can see it's the clockwise rotation and so on. It's doing this default checks and so on. That's so to say, we couldn't completely alone implement this main function because it's like the very big part of the driving logic in it is in it. Okay, so far so good. Let me go here and simply copy everything, because that's what we got. I was asking, but I mean, yeah. We have my answer. We have here go, and we need to find this label bye bye in here. We have that in here to make it easy for us, because it's code has this brilliant copy function. Oh, I haven't used yet the first part of the session. Interesting. Actually, bye bye. We don't need that. We don't need two main functions. And let me clean the program, and let's, before to run the program, to see some kind of expectation with the input. We'll need to see 79 bacons. However, before even start confirming that, the first thing is we need to make sure that we are parsing this input correctly, and we have all the scan data correctly. We have on a line 115 something common that is not used. Okay. Okay, there's some problem with the index, but let's simply debug and see what's going on there. We have all that, we don't care. We have our main function. Okay, that's so typical. What is the problem? In all of our videos it's the same kind of mistake, because it doesn't have the exact input. You can see that, okay, we are parsing the first line, but after that we're going to nowhere. Why? Because our line is simply empty, and we simply need to skip in that situation. Once we're done, we want to have these scanners. In here we need to have the scanners and all the bacons for these scanners. Let me see if that's the case. No, I don't want. I want to check only the first one, actually. One is fine. Okay, I can see the first one more or less looks okay. I have ID is 0. It has this, so to say, 0 coordinates. Let's happen with the second one. Yeah, it's with 1. I have the 0 coordinates. Let me look at the example 686. Okay, perfectly fine. Minus 390. Absolute. Okay, we have this part for reading the input, parsing from the file, and so on, looking absolutely correct, and all of our scanners have initial coordinates x, y, z equal to 0. Let's see how the logic continues. We have this found options that we do okay, probably we I would assume, why, let me ask ChatGPT to explain to us this part of the logic, because at the moment I can see that there is some mistake connected with this part of the logic. For example, if I comment it out and I run the program, I can see some answer. I'm knowing that I'm parsing the thing and assuming that all of the coordinates and everything is as I expected, I will get 127 pagans. But that's simply reading the input and simply assuming that everything is correct, which is not the case. In the task, the main driving logic is here in these bits, and what I want to know is I want GPT to explain to me, could you explain to me step by step how this part of the code works. How this part of the code in the main function works. Okay, let's see what we'll get from this. Okay, this found one present how many scanners being positioned correctly. Let me look again at the code. We have our scanners, and if the founded scanners remains less than a number, that means that not all of them are positioned correctly. Okay, fine. In this case, that's 4. Let me here see what's happened with this number. we have 1 1 1 and it stays 1. Okay, it seems like we never get here or here. Let me close this one. Okay, both are in the most inner loop. And I'm getting range from 1 to 1. But wait a minute. If I have only one that is correct, when I do this kind of thingy, I will always get the same, isn't it? 1 second. Yeah, we can see the same address. For my scanner, but why would I want here when I decide to position the scanners to pick only the first one? Because let me do it like that. Yeah, that's only the first one, which is fine. Probably I'm assuming that the coordinates in this one are our original coordinates, although I'm a little bit confused. Why would I do that with one more loop? Because this I always will be, let me go here, and if I understanding this stuff correctly, I will have I that it's always 0, and this S1 will be always like the same. Yeah, you can see it's 0, and after that point the object that it's the scanner, and that will never change. I mean, in this case I have here this I that it's kind of shadowed. Okay, I think that I simply will simplify it a little bit, this one. And doing this big time magic of having it like simply like that, and let me remove that, move this one. And why I'm checking mine +1, it seems like I'm deciding should I break or not based on something very strange as a logic. Let me let me go back to the explanation, sorry about that. Up until the number of found scanners is equal to the total number of scanners. Okay, that's fine. For each scanner S1 in the found scanners of the index found, for each scanner S2 remaining not yet found scanners, I have only found the first one and remaining not found. Okay, I see why is that this way. I actually was wrong. Please return it and be smart. I need because I'm starting with only one, but after that I can have 2, 3 and so on that are found. However, I'm not absolutely sure that the found one will be exactly on the second position and so on. And I'm breaking this one, the inner loop, because I can see that I'm going outside of this loop. Frequently enough, it's not like, let me do it like that and like that. We can see the 0, which means that this loop gets, okay, that doesn't need to get broken really. Here, what do I get with my S2? There should be, I guess, stop. I'm iterating through them. 4, 3, 2, 1, 4, 3, 2, 1. Okay, it looks like I've never break from this one, which is absolutely fine. Why I never break from this one? I have this access thingy with the eye. I'm stopping if the number of found, let me see here what's going on with this two. Why is bigger or equal? This part of this code like looks very strange. Okay, they stay all the time the same, and that never heck. Okay, now I actually want in this one and specifically this break logic. Because I actually want to, let me add that like a refreshing logic and so on for someone that is looking at this stuff. I know it's a bit looks a bit yes, front. Question. And probably when we have it like that and I paste it, let's see. It uses nested found initialized to 1 as we already know the absolute position of the first scanner. The outer for loop runs until the number of found scanner is equal to the total number of the scanners. That's fine. The second for loop iterates over the found scanners using index sign and value s. Okay, that's fine. The third loop is iterating over unprocessed scanners over the unprocessed scanners. The fourth for loop over the axis. We're checking all of the axis and so on. And for possible rotation. And the fifth for loops iterates over two possible rotation direction, clockwise and counterclockwise. That we have for all of this axis rotation actually to that's very interesting. I think this will be our most loop. I will not read it for now because it looks to me correct. Now let's address the specific break logic you asked about. These lines check if the number of found scanners found is greater than the index incremented by 1. If true, it means that the overlap has been found in the inner loop and the current axis rotation has successfully processed the current pair of scanners. Okay, it seems like that never breaks. But is it that never break because simply we don't found anything anyway? Because we're getting to here, but when I'm looking for the found, I'm never hitting this found condition, obviously. And here I'm looking for 12. Do I have 12? Yeah, I do. I was wondering if I have enough. Yes, I do have 5 scanners. But where are these rotate? Oh, let's see if this rotates. Oh, we have clockwise and here is really the rotate. Oh, rotating stuff. Let me do a very simple check how the beans look before, after. And let me break at that point. Okay, this break doesn't seem to work whatsoever, but let's stop it. I think this Go program is too fast. Oh no, that's not the stop. I wanted to stop it very fast, but okay. Let me see. When I have it like that, new and old side by side, I do my thing. I have my push thingy. New, old. Are they really new and the old? But how they're so say rotated? Let me grab this one. And we have all this stuff, blah blah blah. Let me replace this one with what I want to replace it with this one. Sure. No, not really with this one, but with this one. Okay, nice. And now when I'm looking at this one, is there, can I find this? No, it's only one. but if I look for this number, I have it here and here, and okay, I can see I have 597 being with a different direction. All of them are the same, but this one is positive and negative. If I look at this one, yeah, okay, I see it's simply changing the sign. Okay, this part looks correct. Fine overlap. If I do here print I think it's a bit too much, yeah, and I clean that and run it, yeah, it's running, but never get to overlap. Okay, here in this case I'm making like a new one that I want to find the overlap with the original one and this one. Okay, why it's always doesn't see? Actually, just close that, and this for fine overlapping, because this rotating and changing the axis seems to work fine. I think the probably the place that something is going wrong from what I'm seeing so far is the fine overlapping. And I would want to know specifically for this one actually. Let's go back to this blah blah blah, I don't care. What I want here is deleting this stuff. So I'm not deleting this stuff and pasting this stuff, and specifically this part. When I'm saying, and I'm very interested of this part. Is going that to help? Yeah, 1 second. We do not use the permit value. If statement first call and the rotation. Okay. Okay, that sounds about right. If there is overlap, we find overlap icon between the first scanner 0 and the current scanner. We ignore the boolean return value. Here, since we already know that there will be overlap, again, it's if the first iteration returns the difference, okay, but I specifically it seems like never well. Yeah, let me try with this one little bit. It's interesting that this overlapping. Yeah, I think that the following logic, I don't need to know if it's true or false because it's, so to say, irrelevant in some sense. Let me see. It does not work completely. Correct. Let's see if the generation of alternative solution might have here. Hey. That's completely. When I wanted another solution, I never realized that that's the moment in which I actually wanted to have my main function rewritten, not the entire program, but by any means, if the model is able to generate another working solution, yeah, why not? Let me add this stuff in my Git, simply to have it in my tab and see. We're getting there. Oh, amazing. This time was able to finish the program sooner. Okay, let's see this another type of solution. Okay, it's here is falling apart to actually parse. Now 1 second, why is this? Now I don't like this, to be honest. I want to be like that. And okay, it's crashing because of this parsing, but if I do git diff and look at the other parsing, because the other parsing was fine, No, 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 no. It's too big, too big. Too much stuff. Here I have this kind of. Here's the prefix parsing. This kind of logic because here it's this else branch, so the same is fine. If it's here, where is the scanning part? Now I know that I'm not empty line, and I need to actually have this vector I have this camera is a pain, the line, if it's not okay, for each of these I actually need to put it here in at the end of a given line. If it's a line, and the thing is not zero, I will need to add them. In here I want to add simply the last one, okay. Mm-hmm. Okay, that looks much worse. Mm-hmm. And let me clean this session and simply first I start from fresh one, and secondly actually ask this one as well, this one. Again, I can see one of rotate. Okay, that's interesting. The engine here will provide me all the combos to rotate them. Oh wait, 1 second. Mm-hmm. This option looks interesting actually. Mm-hmm. Many of them are, yeah, and here we're flipping, so I think very interesting. Here already I can see that it's kind of not really correctly parsing the initial input. Okay, that's like with incorrect syntax. This with incorrect syntax. Let's see if we'll be able to do. Back 3. Okay, have our vehicles like that, scanners, M, thinking that this one it's in principle better, although like read the input. I have such a function that it's reading the input. I was thinking what mm-hmm. This rotation and so on, relative positions. Mm-hmm. I think at least the first solution to me looks really like close to be correct. It's interesting in this attempt when it's writing these new attempts, so to say, to satisfy its solution. It looks to me better, but it didn't complete it. I mean, that's very subjective. What's happened with this one? This one seems like a crash. It's interesting that this one it's thinking that it's the code solution from 2017. That's very interesting. This one is searching in the internet and it's suggesting that that's to solve the puzzles together. I haven't seen anyone to solve the puzzle together. Okay. Let me could you feel the missing part? Alright, we'll try with the whole input. it will not work because of the token restrictions. To be honest, I'm thinking to make a break and to continue with the original solution. Let's say this get orientation, it's getting all the combos of different orientations. I appreciate that. But I mean, that will end up okay. To some degree, it's writing a very strange code about that. And skip the rest. I mean, I've never thought the problem it's easy. It's actually okay, that part looks fine. We have this temp vector. Yeah, it's very interesting. Hey, it's claiming that that's too hard. I kind of agree that's too hard. It lets me save and that's one amazing thing because yeah, it's a system. It's a system that imitate that it's a person. So to say it's talking to you like an assistant, but it's actually not. And you can ask over and over and simply ignore what it's saying. Here is going on again with the permutation solutions, which was kind of interesting. Approach to the problem. Transform now find overlap. Probably one thing that I didn't do in my previous attempt is actually to save this variation, because some of them probably had clues. Because this one looks more and more to me at least quite correct. Please finish the main function and skip the rest. But in this case, yeah, I think skip the rest is this four-dimensional vectors and so on. Yeah, that has this message that he didn't find it and so on. No. Okay, we'll do second of pause and we'll continue after that. A big pause. Let's see. I just simply return my package. I check out the previous version that was going to infinite loop, and let's go back to the prompts. So far we have this first prompt, the second one, and let me add another bit at that stage. The task get more and more complicated. Lastly, I was asking for seems wrong and going to infinite loop. Okay, let's try with these bits. This code method is to find relative position of scanners in 3D space. Each scanner has a set of beacons with absolute position. The code attempt to find overlap between the beacons of a different scanners after rotating them along each axis. Here's step by step. Let's go to this initializing the value and so on, because we have here found, we have the found, we're going scanner, we found that up to here the logic seems correct, but here never breaks and actually never hits this found. If so, it breaks out of current access loop and proceeds to the next scanner in the list. To prevent infinite loop by stopping search overlapping. But it seems that never. Okay, I don't think I should continue iterating, and here I should here is the code. Let me go to the direction of giving the entire code. While I'm doing that, I would want to actually and I would want actually to have it and fix the solution. More and more I'm thinking about to have some automated way of evaluating this code and to go to here. Let me put my question. That's my question. Okay, let's break down the code and I'll explain purpose of the code and propose solution to fix it if necessary. The main functions first read the input data from a file and stores the data in list of scan structures. Each scanner has an ID array of beacon and absolute position. After reading the data, the code attempts to align the scanners by rotating their beacon and finding overlaps between them. The part of the code you have concern about is follow. The outer loop for len iterates until found is equal to the total number of scanners in the inner loop. The code tries to align the current scanner S2 with the previous aligned scanners S1 by rotating S2's beacons and checking if they overlap with S1 beacon. The breaking logic you're concerned about is breaking statement prevent necessary iteration over match S if found has been. This breaking statement prevents unnecessary iteration after a match has been found if found has been incremented in the inner loop. This means that the current scanner S2 has been aligned with the previous scanner S1. As a result, there is no need to continue iterating the axis and rotation for the current combination of S1 and S2. The break statement stops the current axis loop and move on to the next scanner. However, there is indeed a problem with the code. The breaking statement inside the loops will only break out of the innermost loop. The loops iterate over axis and clockwise values will continue for each overlap had been. To address the issue, you can use a label to break the loop. Found scanner outer loop. Okay. Interesting. It's telling me to go to again here and to start from the beginning. I actually think that it's really found plus plus. I think actually that's I think actually this suggestion probably it's working, but again I can clearly see that that's not changing anything. Let me try one more time. Let me force it downstate it. Did solve the problem that okay, let's submit the feedback and let's see if another proposed solution might actually find next scanner. Okay, here it's trying to do something else. It's putting that in its own entire function. Find scanners. Yeah, interesting approach. Actually, I think that's probably a valuable idea. and here to have in the main function, instead of having all this stuff, have instead this one. Does help with anything? It doesn't seem so. Okay. Either answer is better. I think that's hard enough. Let me try second time. Yeah, I think it's again not successful. Attempt. Yeah, I will prefer to simply try another day and give each day 1 hour or so trial, and if it doesn't work, simply to move on and to see which one I might be able really to solve. Go to statement and make the code. Yeah, but that doesn't. I already have, so to say, such a version. Okay, let me go again to this one. Which is doing the same thing over and over. I mean, so it's fine. I mean, this go to. I didn't know that go has go to. I mean, and 21 because I don't use this one. Okay, but do I have really this go to? I have go to. Okay, my dream is true. Isn't it the same thing like using break? Yeah, the same thing. Okay, let me say that I think what's the key actually breaking point is find overlap and rotate down. I think in my last attempt to revisit this part of the code, I'm not concerned. Actually, I think this and this if object again. That's the was bit that I'll try once and once with the mistake, and we'll move simply forward. Let me paste the last version, this stamps, and let me have it like answer here, and let's see. The problem occurs when you have overlapping scanners but they don't share the same relative position. The code will be keep incrementing found without updating the scanner's size, thus causing the loop to run infinite. Unchanged code. Okay, it's telling me here in this found part simply to grab these bits. Yeah, stop pasting this stuff because of the okay. No, it didn't help, but that's it did not solve the problem with the infinite loop, which is absolutely fine. Again, okay, it gives a little bit different logic. Let me put it here. 1 second. Tak. It's already running. Just stop it. Data bacon, it's wrong. I think it's a better answer, but yeah, I'm not It's simply too hard to judge, I think, on this stage. Let me do my attempt with the real input, simply to see that it's not working. Just scanner position. I think that's the final one. I mean, none of them was really better. I think and that stage is apparent that it's simply too extreme amount of limitation and big part seems to be more related to ability to execute code and so on. I hope that there some way of doing that. Okay, I mean, this number looks completely wrong, but let me give a try. My answer is too high. Okay, I'm committing this one, and hopefully see you in day 20 and try to see above day 17 if there is any other day that can be solved, and after that might look again at the challenges and try to identify the problems. Thank you for your time, and hope you learn something. Bye.